So I've been making all sorts of silly mistakes going through this problem. So I'm just going to start it from scratch. We'll go from there. So we've got the graph of f prime here. So here's a graph of f prime. And then it says we want to find a few different things. And we're given this initial condition here, and that's going to help us solve something. So the first thing it wants us to do is find the values of f of -6 and f of 5. So the first thing that we can say is that we can say that the integral of f prime is going to be equal to our original function, more or less. So when we go in there, and there's some initial condition on this, so there's going to be some things that mess with it a little bit, but if I'm trying to find that, what we can do to handle this for part A is we can say, well, I do know that from -6 to -2, that's this triangle that I can find the area of. So we can say the integral from -6 to -2 of f prime of x. And using the fundamental theorem of calculus, I know that that's going to be equal to f of -2 minus f of -6. Remember, because if the derivative of f is f prime, then the integral of that will be that. So the cool thing is I can find the area of this first shape, and let's find the area of these three shapes right now. So we know that from -6 to -2, it's a 4 and it's a 2. So the area of that is 1/2 times 4 times 2. That's 1/2 times 8. So the area of my triangle is 4. Semicircle that goes from -2 to 2. We know that that's pi r squared, but it's only half of it. So 1/2 pi 2 squared. So that's 4 over 2 pi, or just 2 pi. But since it's underneath, it's going to be -2 pi. Remember, over we add, under we subtract. So we got 4, we got -2 pi, and then our last one is this triangle with a base of 1, 2, 3, and a height of 2. So 3, 2, so that's half of 6, which is just 3. Okay, so those numbers are going to come into play at some point, I'm sure. So let's see. So here, I know that from -6 to -2, the area is 4. So we're going to say 4 is equal to, and then we know that f of -2 is equal to 7, but we don't know f of -6. Well, hey, look at that. That's an easily solvable algebraic equation. So we just divide by -1, and we get 3 is equal to f of -6. So that's the first part. In part B, if we want to know what f of 5 is, the thing is we're going to need from -6 to 5. It's the accumulated area all the way up. But remember, the accumulated area, it's also going to take into account our initial conditions. So our initial, we don't actually know the like whatever the original area was that we started before we started adding this on, but we do know that what f of 2 is. And so I can't just take all this and add this up. Instead what I need to do is I need to say that I know that f of -2 plus the integral from -2 to 5 is going to get me some area. Or, sorry, whatever f of -2 is plus that's going to be the integral. Brain, let me pause for a second. I'm sorry. Let me just collect my thoughts. Okay, I was way overthinking this. I'm still on part A. Why did I write part B? So, still on part A. If we want f of 5, Well, I'm going to use information that I already know. I know that I can find the area from -2 to 5 of our derivative that we've got graphed. And I know that that's going to be equal to f of 5 minus f of 2. So using the numbers that we got earlier, we know that if we take our area and add it up from -2 to 5, we get -2 pi plus 3. And that is equal to f of 5 minus f of 2. And f of 2 we know, it's 7. It told us in the problem it's 7. So now I just got to solve for f of 5 by adding 7 to both sides, and I got -2 pi plus 10. So there's that one. There's our f of -6. I don't know how chopped up this is going to be, and I'm sorry about the messing up, but we'll just keep going. I need to have more confidence in myself and not check the answers so much, because it's when we check the answers that we screw ourselves up sometimes. All right, let's see, part B. On what intervals is f increasing? All right, well, I know that f is increasing when f prime of x is greater than 0. So I'll check here, and let me look at my graph. My graph is greater than 0 from -6 to -2. Which occurs on the interval from -6 to -2, and then from 2 to 5. And notice I'm using parentheses to indicate that we're not sure if we're going to include those endpoints or not. All right, let's look at part C. Find the absolute minimum value of f on the closed interval -6 to 5. Now, since it's asking me to find the absolute min, I'm going to need an x and a y coordinate. So let's see. Absolute minimum. Well, absolute minimum could occur at either endpoint. So I need to check my two endpoints. So let's see, well, f of -6, we got it earlier, and it was equal to 3. And then f of 5 was equal to -2 pi plus 10, which is approximately 3.7 something. So right now, f of -6 is my main contender, and my other option are at critical points. Remember that a critical point occurs when f prime is equal to 0. Well, let's see. F prime of x is equal to 0 at x is equal to -2 and 2. And also 5, but we've already taken care of 5. We know what f of 5 is. So I want to find out what f of -2 is. Oh wait, f of -2 is equal to 7. So still, so far, our main contender is at -6. Now, my bad, I'm sorry. We'll check out, we just got to check out what f of 2 is then. And we know that f of 2, we can use that same idea. We know the integral from -2 to 2 of our derivative. We know that that integral is going to be equal to f of 2 minus f of -2. So let's see. We know that area is -2 pi. We found that earlier. And we don't know f of 2, but we know that this is 7. So -2 pi plus 7 is equal to f of 2. Now that's only 1 point, or that's less than 1, because 2 pi is about 6.28. So because of that, we know that 2 comma -2 pi plus 7 is going to be our absolute minimum. So if you want a different way to look at that, the way that they did it here was they So they kind of said the same sort of thing. They try some stuff out, and we got the same answer. They just do it a little bit differently. All right, so now let's look at our final part, part D. For each of f double prime of negative 5 and f double prime of 3, find the value or explain why it does not exist. All right. Well, so f double prime of negative 5 is equal to f prime of negative 5's slope. Let's see. Negative 5 is over here, so the slope there is down 2 over 4, or negative 1/2. And then f double prime of 3, so the slope from the left-hand side is 2 over 1. The slope from the right-hand side is negative 2 over 2. So 2 is not equal to negative 1. So the left and right hand limits do not agree. Or the left and right hand slopes do not agree. So f double prime of 3 does not exist. All right. So in case you missed this, I might have gone through it a little bit too quickly. The f double prime is just f prime of f prime. It's the slope of our picture. So find the slope of the picture. Slope there is just a line, so I can do rise over run. Slope here, issue is, since it's at a point, a sharp point, can't do it. So, womp womp.